Hello, this is College Drive doing some math. Today in Algebra 1, we're going to interpret box and whisker plots. A box and whisker plot is a data display that organizes data values into 4 groups. Each group is a quarter of the data, or 25%. There's a lower quartile, which represents the lower half. Upper quartile represents the upper half. And it helps us find outliers. Outliers are basically it's a value in your data set that's widely separated from the rest of the data in the data set. So basically, if you were, so in example 1, we're looking at heights, and there's the tallest people in the world and the smallest people in the world. And if you're looking for the average height, the tallest and the smallest people, most people are not the tallest or close to the tallest. And they're also not very close to the smallest person either. So you would take the smallest person and the tallest person, or any of those outliers, and throw those numbers out because those will affect the data. Now, so you're just looking for any numbers. So like, if most of your numbers were in a certain range, and then there's one that's just outside, basically outside the box, like, so pretend if all your numbers were between 30 and 50, and then you got one number that's 100. That would be an outlier because most of your numbers are around 30 to 50. It's okay to be 29, 27, 55. That's a little high, but if you go as far as a huge difference of 100, that's considered an outlier. Let's do some examples. So make a box and whisker plot of the heights in inches of 7 family members. So first you want to do is rearrange them in order. So 34, 46, 54, 62, 70, 67, 70, 75. Okay? And then now we need to find our median. So remember, our median is the very center. So I'm just going to do little check marks, count one from the left, one from the right, until I get to the middle. 2, then 3. Okay, so we do have a median, a middle number. So this is the median. Okay, I like to circle that. Okay, and then what the median does is helps us split the data in half. So we have this section, and then we have this section, lower and upper half. The lower quartile, also known as LQ or Q1, is the middle of the lower half. So 34, 46, 54, the one in the middle is 46. The upper quartile is the same thing, but it's for the upper half. It's the middle of the upper half of the data. Okay, so there's my lower quartile, median, and upper quartile. Now, let's plot this. So how do we plot this? So we have a number line here. Okay, and it represents basically all the data, 30 through possibly 80. And we're going to mark our medians and quartiles. Okay, so we're going to plot median, quartiles, minimum, and maximum. Okay, so our minimum is 34. So that's probably here. And then you're going to mark, you're going to label. 46 is here. $62 is here. And 70 is here. And the maximum value is 75, so 72, 74, around here. Okay, so label all these. 62, 70, 75. Okay, so what you want to do is go ahead to your quartiles and medians and draw a line. Not too tall, not too wide. But make sure they're all the same length here. And then connect them, making a rectangle. So here's the box, inbox and whisker. And then our two whiskers are like that. And that's how you do it. So plot your median, quartiles, minimum, and maximum. You draw your lines at median and quartiles. You make a box and then attach your whiskers. Alright, let's do another one. Okay, make a box and whisker plot of the data. So we need to rearrange these in order. So 2, 3, 4, 4, 5, 5, 2, 3, 4, 4, 5, 5, 6, 8, 8, and 10. Okay. Now you want to find the number in the middle. Three, 4. Okay. So the number in the middle the number in the middle is the average of these two numbers, and since they're both 5, the median is 5. Okay. The lower quartile is the middle of the lower half. So we got the lower half here. The middle is 3 and 4. So we need to find the average. Average is 3 plus 4 divided by 2. So 7 divided by 2 is 3.5. And then the upper quartile is 8. Because the number in the middle of the upper half is 8. 8 and 8. So the average between the two is 8. Okay. Now we're going to create a number line. Let's see. Let's start at 2. 3, 4, 5, 6, 7, 8. Okay, and you'll want to give yourself more space than that. So let me see if I can do that here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so our lowest value is 2. Our lower quartile is 3.5. Our median is 5. Our upper quartile is 8. and our maximum value is 10. So I'm going to draw my vertical lines at my quartiles and my median, then connect them, and then draw my whiskers. And don't forget to label your points, which this is 8 and this is 10. Okay. The boxed and whisker plots below show the average high temperatures in degrees Fahrenheit each month in Atlanta, Georgia, and in Orlando, Florida. For how many months is Atlanta's average high temperature less than 60? So we go to Atlanta's box and whisker plot there. So that's that upper one. So for how many months is Atlanta's average high temperature less than 60 degrees? So we look at 60, and it's 60 degrees is the lower quartile. So the lower quartile represents 25% of the data. So that means 25% of the time, the average high temperature is less than 60 degrees. Okay? So if I would say the median, if I wanted to say how many months is Atlanta's average high temperature less than 73 degrees, that would be the median, and that represents 50% of the data. So 50% of the time. And same thing with the upper quartile, that's 75%, and then the maximum value represents 100% if you're doing less than. Compare the average high temperature in Atlanta with the average high temperature in Orlando. Okay, so the temperature, the temperature in Atlanta fluctuates because you got this big range of 60 to 84.5. So that's what you want to look at. You want to look at most of the data. Most of the data is in the box of the box and whisker plot. So in the box, it represents most of your data. So Atlanta fluctuates more than Orlando. Orlando tends to be higher than Atlanta. So if you look at Orlando, most of its readings is between 76.5 and 90.5, while Atlanta's ranges from 60 to 84.5. So on most given days, Orlando will probably be hotter than Atlanta. Based on this data. And then based on geography and, where they're located, Orlando's farther south, so and closer to the equator, so it gets hotter. Checkpoint 2. In example 2, how many months was the average high temperature in Orlando more than 84 degrees? So we're looking at Orlando, 84. 84 is the median. And we want to say how many months was higher than 84. So remember, the median represents the middle of the data. So 50% is higher than 84 degrees. And also 50% is lower. So this, again, is the median for Orlando. Okay, example 3. The average monthly high temperatures in Atlanta are 52, blah, 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 blah. These data were used to create a box and whisker plot in example 2. Find the outliers of the data set, if any. Okay. So we're still using the box and whisker plot, or at least we can use that. So they already rearranged it and everything. To figure out an outlier, if a number is less than, so we got two formulas here. If there is a number less than the lower quartile minus 1.5 IQR, that's the entire interquartile range. The interquartile range is found by taking your upper quartile and subtracting your lower quartile. Okay. So if you find a number that's less than the lower quartile minus 1.5 IQR, then it's an outlier. Or if you find a number that's greater than the upper quartile plus 1.5 IQR. So let's find the IQR so we can have a number. So the upper quartile of Atlanta is 84.5. So if I'm looking at the data here, we have the upper quartile, lower quartile, median, minimum, maximum. So 84.5 for the upper quartile. Lower quartile is 60. So upper minus lower is 24.5. Okay, so let's figure it out. Were there any numbers less than 60 minus 1.5 times 24.5? Okay, so this is 23.75. So is there any numbers here in the list of numbers, the data, anything less than 23.75 degrees? So none here. Okay, let's do the upper quartile. So upper quartile is 84.5 plus 1.5 times IQR, which is 24.5. And that'll give us a temperature of 108.25. Is there any temperatures greater than that? So no outliers. Alright, let's do that again. So this time we don't have a box and whisker plot, so we need to find our median, lower quartile, upper quartile, and our IQR. Okay, so first thing we need to do is rearrange them. So 9, 15, 19, 20, 22. So 9, 15, 19, 22, 25, 26, 29, 30, okay, 20, wait, yeah, 22 is there, 25, 29, 26, 30, 32, 33, and 49. Okay, so in the middle, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Okay, the middle are these two numbers. Okay. So what you want to do is, I believe I messed up on one of the examples. I forgot you have to do this. But it's okay if you do it either way on my test because I messed up. You want to put a line in between the very center. So it's in between these two numbers. One second. So I did mess up on the earlier problem. So I had 5 in the middle. There are two 5s in the middle. You take the average, so you need to put a line in between them, and that represents the lower half and the upper half. So the lower half would have been 2 2, 5, 3. Huh. Wait a minute. I'm gonna have to look this one up, but I'll finish this up. Alright, so this was a little tricky. So when you're figuring out your median, so in this upper one it was 5, you draw a line in between them, and you want to exclude your median when calculating lower and upper quartile. So what I did was right before. I excluded 5, so everything was right in this first checkpoint. Down here, the median is the average of 25 and 26. So that is 25.5. That's in between the two. If you add them together and divide by 2, that's what you get. Now we're going to exclude the median, though the median is 25.5, so that doesn't exist. So that's why we create the line there. And now my lower quartile is the numbers 9, 15, 19, 20, 22, and 25. So the middle of that is, so 9, 15, 19, so 1, 2, 1, 2, so 19 and 20. So 19 and 20, between that is my lower quartile, so that is 19.5. My upper quartile will be 2, 3, between 30 and 32. So that is 31. So my IQ, my interquartile range is 31 minus 19.5, which is 11.5. Okay. Now, we need to find any outliers. Okay, so if there's any numbers less than the lower quartile, minus 1.5 IQR, then it's an outlier. So 19.5 minus 1.5 times 11.5. So is there any data less than 2.25? No. Okay, let's try the upper quartile. Upper quartile plus 1.5 IQR. 31 plus 1.5 times 11.5. And we'll get 48.25. Do we have any numbers here? That's an outlier. 49 is an outlier because it's bigger than 48.25. So what do you do with outliers? You would toss them out of the data and then create your boxing whisker or your histogram. You would calculate your average, and that you would exclude that from the data and then use the rest to make your calculations to find the average, to find where most things lie in between, and stuff like that. All right. And that's that for today. Sorry for a little confusion there. But once again, the confusion was if you have an even number of data and you're trying to find the median, you would take the 2 and add them together and divide by 2. You would take the average. And then you would exclude the median from calculating your lower quartile and your upper quartile. In this case, the median was 5, so we had to exclude it in calculating lower and upper quartile. Down here, it's 25.5. That doesn't exist on the list of data, so we don't exclude anything. We put the line, and that separates our lower and upper half. All right, have a good day.